Now this is unit 10 S block element. Now we will discuss here with chapter number 10 S block element. In case of S block element, first of all see, in complete periodic table element, whenever we are writing electronic configuration, and suppose if S orbital will be valence orbital, if S orbital will be valence orbital, then that type of elements are included in S block element. Clear? In S block element, the periodic table are those in which last electron enters the outermost S orbital. Whenever we are writing electronic configuration, then last electron enter the outermost S orbital. Clear? S orbital can accommodate only two electrons. So two groups 1 and 2 belong to the S block of the periodic table. Clear? Again I am repeating, you know very well that in S orbital can accommodate only two electrons. So two groups 1 and 2 belong to the S block of the periodic table. In group 1, which elements are there? Here hydrogen, lithium, sodium, potassium, rubidium, cesium and francium will come. In case of group 1, hydrogen, lithium, sodium, potassium, rubidium, cesium and francium will come. So these elements are known as alkali metal. These elements are known as, again we can say that, alkali metal. So these are so called because, why they are known as alkali metal? Because they form hydroxide on reaction with water, which are strongly basic in nature. Clear? So these are, मतलब whenever group 1, so whenever we can say that group 1, जैसे ये M+1 combined with water, so here MOH will be there, and then after hydrogen will be one of the byproduct. So this MOH is again strongly basic in nature, alkaline in nature. Clear? So why this is normally known as alkali metal? Because whatever product will form, so they are, we can say that, strongly alkaline in nature. Clear? Now in group 2, in group 2, beryllium, magnesium, calcium, strontium, barium and radium. So this is normally known as alkaline earth metal. So this one is nothing but it is normally known as alkaline earth metal. So these elements with the exception of beryllium, are commonly known as alkaline earth metal. So these are so called. Why they are known as alkaline earth metal? Because they are oxide and hydroxide. This is oxide, and then after hydroxides are alkaline in nature, and these metal oxides are found in earth crust. These metal oxides are again found in, we can say that, earth crust is there. Clear? देखो यहाँ पे why these elements are known as alkali metal, उसका reason दिया है, और यहाँ पे why these elements are known as alkaline earth metal, उसका reason दिया है. Clear? Here beryllium is exceptional element. It is not included in case of alkaline earth metal because it is electron rich. From complete periodic table, here we can say that from complete periodic table, here see beryllium is electron rich in nature, while boron is, again we can say that, electron deficient in nature. Beryllium is electron rich, while we can say that here boron is electron deficient in nature. Clear? So now on the basis of, see, जैसे ये S block है, तो here in case of S block, so this is group 1, group 2, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Clear? Then after beryllium, magnesium, calcium, strontium, barium, radium is there. Clear? So this one is nothing but it is normally known as alkali. इसको क्या बोलते हैं? alkali group and this one is alkaline. The source of group 1 is again we can say that plant, and source of group 2 is again we can say that here earth crust will be there. Clear? So now on the basis of percentage, here this group 1 and group 2 related elements are further divided into different category. तो चलो इसमें जैसे देखो, among the alkali metal group 1 की बात हो रही है. Among the alkali metal sodium and potassium are abundant, and lithium, rubidium, cesium have much lower abundance. देखिए लिथियम है ना, रुबिडियम है, सीजियम है. मतलब from this group 1, here out of this group 1, sodium and potassium are abundant in nature, while lithium, rubidium, cesium have much lower abundance, मतलब percentage. And francium, you see, so francium is radioactive in nature. Francium, so this one is francium. So francium is highly radioactive in nature, and its long life isotope means francium 223 has a half life of only 21 minutes. Here we can say that half life is again means 21 minutes. So this is complete basic information of group 1. This is complete basic information of, again we can say that group 1 is there. Clear? Now so this one is related with respect to group 1. Now we will discuss things related with respect to group 2. So of the alkaline, so this is alkaline earth metal, calcium and magnesium, rank 5th and 6th. देखो, calcium, magnesium, this one is 5th and this one is 6th rank is there in abundance respectively in earth crust. Strontium and barium, see here we can say that strontium, this one is strontium and this one is barium, have much lower abundance. इसका क्या होता है? तो this one is lower abundance. Strontium and barium have again we can say that lower abundance. Clear? Now beryllium. So beryllium is again rarest one. Beryllium is rarest one, and radium is again we can say that rarest one of all, comprising only 10 raised to minus 10%. Only 10 raised to minus 10% of igneous rock, है ना? ये पत्थर में से मिलता है. Clear हुआ कि नहीं? And beryllium is again electron rich. Now general, here we can say that general electronic configuration of S block element is noble gas NH1. Here we can say that noble gas NH1 for alkali metal and noble gas NH2 for alkaline earth metal. तो यहाँ पे क्या आ जाएगा? Here NH2 and here we can say that NH1. NH1 and NH2 is there. Clear? So lithium and beryllium, the first element of group 1 and 2 respectively exhibit some properties which are different from those of the other member of the respective group. मतलब see here lithium and beryllium, is unique as compared to other element of same group. Lithium and beryllium is unique as compared to other element of same group. Clear? So that type of property is nothing but it is known as anomalous property. Clear हुआ? In this anomalous property, they resemble the second element of the following group. So thus lithium shows similarity to magnesium. Here we can say that lithium shows similarity with respect to magnesium. देखो, lithium is related with respect to magnesium and beryllium. अब देखो यहाँ पे group 13 की यदि मैं बात करूँ तो here boron, aluminium, gallium, indium, thallium. तो यहाँ पे क्या आ जाएगा? Beryllium. तो beryllium is again resembles property, मतलब similar property from aluminium. तो lithium shows similarity to magnesium, while beryllium will show similarity to aluminium in many of their property, and this type of property is known as diagonal relationship. Clear हुआ? तो this is known as diagonal similarity, is commonly referred to as diagonal relationship in periodic table. So what is diagonal relationship? If our element is related with two different group, but so many physical and chemical property will remain same, So this is normally known as diagonal relationship. Clear? The diagonal relationship is due to the similarity. Number one, here we can say that ionic size. Number one is ionic size, or second one we can say that charge upon, here we can say that radius ratio. Charge upon radius ratio. So diagonal relationship is due to similarity in ionic size or charge upon radius ratio of the element. कोई पूछे ना कि why, on the basis of which parameter you can say that these elements are diagonally related. तो क्या बोलने का, first parameter is ionic size and second one is charge upon radius ratio. Clear? तो monovalent, mono मतलब single, sodium and potassium ion, and divalent मतलब magnesium and calcium ion are found in large proportion in biological fluid. जो biological fluid होता है वो, these ion perform important biological function such as maintenance of ion balance and nerve impulse conduction. Clear? So what is importance of these ion? So these are important with respect to biological function. These are important with respect to biological function. Which one? Maintenance of ion balance as well as we can say that nerve impulse conduction. Correct? Now in chapter 10, this is topic number 10.1. Now we will discuss one by one group 1. First of all, we will discuss here means group 1 related element, and then after group 2. Actually S block is further divided into two parts. So 50% portion is related with respect to, here we can say that group 1, and 50% portion related with respect to group 2. तो group 1 वाले को क्या बोलते हैं? Alkali metal. So this one is nothing but it is normally known as alkali metal. तो alkali metal में आपको क्या करना है? See, so alkali metal shows regular trend in their physical and chemical properties with the increasing atomic number. It means if Z will increases, here physical and chemical property will also changes. If here atomic number will increases, then physical and chemical property will also changes. The atomic and physical and chemical property of alkali metal are discussed below. So now we will discuss here means see atomic as well as physical and chemical property of alkali metals. Clear? So out of this here means first of all we will discuss electronic configuration. First property. Second one is atomic and ionic radii. Third one is ionization enthalpy, and fourth one is hydration enthalpy. Clear? So now one by one we will discuss here these four important properties. So out of that here first of all electronic configuration. See this is hydrogen. So Z is 1. So 1 is there. Then after here we can say that lithium. Z is 3. So 1 is 2. 2s1 is there. Then sodium. So Z is 11. So 1s2, 2s2, 2p6, 3s1 is there. Clear? Similarly potassium. In case of potassium 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 is there. मतलब whenever we are writing electronic configuration, then here means general formula of group 1 will be NS1. And as we are going above to below, here value of N will increases. It will be again we can say that 1, 2, 3, 4, 5, 6 and 7. Clear? Now all the alkali metal have one valence electron, that is NS1, outside the noble gas core. नोबल गैस का मतलब जैसे देखो अब ये लिथियम है, तो यहाँ पे हम लोग क्या लिख सकते हैं? तो दिस इज हीलियम and then after 2s1 is there. In case of sodium we can write down neon and then after 3s1 is there. Clear? So now here देखो the loosely held s electron in the outermost valence shell of these element makes them the most electropositive. ये जो इलेक्ट्रॉन है ना, इलेक्ट्रॉन रिलेटेड विथ रिस्पेक्ट टू s ऑर्बिटल, तो लूजली बॉन्डेड, क्लियर। तो लूजली, हियर वी कैन से दैट लूजली बॉन्डेड इलेक्ट्रॉन, तो मोस्ट इलेक्ट्रोपॉजिटिव मेटल, तो दे इजीली lose electron to give monovalent M+1 ion, M+1 ion, hence they are never found in free state in nature. So this is reason why these elements will be not available in free state in this nature. तो देखो पोटेशियम दिया हुआ है, रुबिडियम 1s2, then after 2s2, 2p6, 3s2, 3p6, 3d10, and this one 5s1 is there, 1s2, 2s2, 3s2, 3p6, 3d10, 4s2, 4d10, this one here xenon and 6s1 is there. Similarly francium, so radon and 7s1 is there. मतलब see, in case of group 1, if we are going, in case of group 1, if we are going above to below, in case of group 1, if we are going above to below, here see 1 electron will be added here. N is equal to 1, 2, 3, 4, 5, 6, 7 is there. Clear? So whenever we are going above to below, therefore this is hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. If we are going above to below, here what will happen? Here see 1 cell will increase here. Clear? So now we will discuss here second important topic, that is atomic and ionic radii. So see definition, and we can say that importance of atomic and ionic radii will be given in chapter number 3. Clear? So what is atomic radii? देखो, तो जैसे ये एटम है, तो दिस इज न्यूक्लियस और ये आपका K सेल है, तो डिस्टेंस फ्रॉम सेंट्रल पार्ट टू आउटर मोस्ट सेल, तो दिस इज नॉर्मली नोन एज रेडियाई. सपोज इफ दिस रेडियाई इज रिलेटेड विथ रिस्पेक्ट टू एटम, तो दिस इज नॉर्मली नोन एज एटॉमिक रेडियाई, एंड व्हेनेवर इट इज रिलेटेड विथ रिस्पेक्ट टू आयन, तो दिस वन इज नॉर्मली नोन एज आयनिक रेडियाई. क्लियर? नाउ alkali metal atom have the largest size in particular period of the periodic table. Clear? The alkali metal atoms have the largest size in a particular period of the periodic table. With increase in atomic number, the atom become larger. So whenever we are going above to below, so this is Z is 1, Z is 3, Z is 11, Z is 19. Clear? So whenever we are going above to below, here atomic number will increases. Clear? So monovalent ion M+1 are smaller than the parent atom. So what is parent atom? जैसे देखो सोडियम है, तो सोडियम is 281, तो here Na+1, तो 28, तो here see R of Na is more as compared to R of Na+1 is there. Clear? So size of Rna is more as compared to R of Na+. Sound right? Now the atomic and ionic radii of alkali metal increase on moving down the group. It means if we are going hydrogen to francium, then atomic and ionic radii of alkali metal increases on moving down the group. That is, they increase in size while going from lithium to cesium. It means see, whenever we are going lithium to cesium, here we can say that size will increases. If we are going lithium to cesium, here we can say that size will increases. Clear? Chalo. Now next one, ionization enthalpy. So what is meaning of ionization enthalpy? So this is thermodynamic parameter. एंथैल्पी का मतलब होता है हीट, इसका मतलब H आता है, H. एंथैल्पी मतलब होता है H. तो आयोनाइजेशन, तो एंथैल्पी और एनर्जी which is required to ionize any material, it is normally known as ionization enthalpy. एंथैल्पी मतलब हीट, तो एनर्जी which is required to ionize any material, it is normally known as ionization enthalpy. the ionization enthalpy of alkali metal are considerably low and decreases down the group from lithium to cesium. If we are going above to below, the ionization enthalpy will decreases. So this is because the effect of increasing size outweigh the increased nuclear charge, and the outermost electron is very well screened from the nuclear charge. Clear? If we are going, see, if we are going above to below, here means ionization enthalpy will decreases. Reason क्या होगा? Size will increase. If size will increases, then nuclear attraction will decrease. Clear? तो वह याद दिया है. The ionization enthalpy of alkali metal are considerably low and decreases down the groove from lithium to cesium. This is because the effect of increasing size, है ना? Size बढ़ेगा, outweigh the increased nuclear charge, and outermost electron is very well screened from the nuclear charge here. So that is complete information of ionization enthalpy. Clear? Then next one, hydration enthalpy. So what is meaning of hydration enthalpy? The enthalpy which is required to hydrolyze any material. या तो आप ऐसा बोल सकते हो कि whenever we are dissolving any material inside water, तो whatever amount of energy is required, it is normally known as hydration enthalpy. अब यहाँ पे क्या होगा? See, it will decreases. Hydration enthalpy will decreases with increase in ionic size. जैसे लिथियम का देखो, तो लिथियम क्या है? Hydration enthalpy of lithium is maximum and cesium is minimum. Why? Because size of lithium will be small, so nuclear attraction will be more, so stability will be more, and if stability will be more, so we have to supply more amount of energy. Clear? So lithium plus has maximum degree of hydration, and for this reason lithium salts are mostly hydrated, just like LiCl.2H2O. Clear? So this is complete information. ये है ना, इससे रिलेटेड 1 मार्क्स के क्वेश्चंस आते हैं. लिथियम, सोडियम, पोटेशियम, रुबिडियम एंड सीजियम. क्लियर? तो दिस इज कंप्लीट इंफॉर्मेशन.